All right, everyone, we've gotten to the good stuff. You ready? Starting with compound interest. Now we're starting to get into this stuff that's really interesting. So when we have interest, we've been using a simple formula. It's great, it's quick. But most of the time, when you're getting interest, you're also building interest on the interest that you've already acquired, right? Like if I have $1,000 in an account and I get $5 of interest after a year, well, now I have $1,005 that's getting interest. I'm going to get more than $5 the next year. And then I'll have more than $1,010 and I'll get more and more interest. So the interest builds and we get this exponential growth. And so the formula to calculate this is a little bit more complicated than the earlier formulas. And here it is. I'm not going to go into too much depth on where this comes from, although it's very, very cool. Very cool. But here it is. Yeah, I'll hold myself back for you guys. So here's the amount. Sometimes this is called A. It's the amount after N years. It's our balance after N years. It's the principal, the initial deposit, times, forgot my mouse wasn't actually in the window, so I was gesturing to things and you couldn't see. It's the principal times 1 plus the interest rate divided by this K. Now, K is just going to be how many times it's compounding in a year. So if it's compounding annually, that's once per year. Annually would be, here, it's probably a good thing to write down. Annually would be once per year. That means K equals 1. Semi-annually, that means twice a year. That's going to be K equals 2. Quarterly, that's going to be 4 times a year, every quarter of a year. And then monthly is another really, really big one. Well, if it's compounding monthly, how many times does a month happen in a year? Well, 12 times usually. We usually have 12 months. Although who knows, maybe one day we'll have 13 months. That would be so much nicer. Anyway, I'm going to withhold my month changing agenda and just talk about math. So much holding back I have to do today. And then again, just remember that the annual interest rate is in decimal form for this R. Okay? So, it's already written down in your notes right here. Yeah, so that's important, guys. Annually, semi-annually. Oh, I gave you a bonus one. And then daily would be, we'll assume 365 days a year. Yes, sometimes there are 366 days in a year. You could do 365 and a quarter. Let's get mathing. Okay. So one specification, this remark is not super important yet. It'll come into play later. So we're going to ignore it for now. So Uncle Moneybags, the same guy from the last video, he's giving nephew starving actor $2,000 to deposit into a savings account earning 3% interest. Which again, 3% interest with inflation is not good, but anyway, Uncle Moneybags is not Uncle Moneybags for no reason. He's not. Anyway, $2,000 into an account with 3% interest compounded monthly. This is our initial deposit. This is our P naught. This is our interest rate. Convert it to a decimal and it'll be our R. Compounded monthly, that's information about K. So whenever we're using, especially these longer formulas, it's always recommended to copy the formula again. So we're going to be using compound interest. Let's copy this formula down, okay? And that formula says, for example, 7.4 Pn equals P naught times 1 plus R over K to the NK. It's much easier to use a formula if you have everything written down. And now we just go to our example and say, what are all of these things? Pn, this is the amount after n years. Well, we want to know about 20 years. So this is what we're trying to find. we're trying to find Pn, and specifically, n is the number of years. It's P20 that we're looking for. So since n is 20 years, right, if two things in math are equal, they're the same, we can just replace one with the other. Replace that n with 20. Perfectly fine. What's the principal? What's the initial deposit? 2,000. So replace the P naught with 2,000. 1 plus R is our interest rate. 3% interest rate, so R is 0.03. Convert it to a decimal. Divided by K. We're compounding monthly. So if we're compounding monthly, K is 12. Raised to the N, which is still 20, times K, which is 12. So you can see here, and we're not even that close yet. We're not even to the end of the chapter yet. And it's already getting more complicated to type into a calculator, okay? Which is where Desmos is helpful. We want to type this in exactly into our calculator. So let's check this out and see how it goes. Here's what we're going to do. Type in 2,000, and then the parentheses, just like before, 1 plus 0.03. Divide this using the fraction, using the forward slash, and it'll automatically put it as a fraction, forward slash 12. You don't have to use Desmos, by the way. You can use a computer, you can use another website, you can use your calculator, whatever you want to use. This is what I recommend, but as long as you get the right answer, you can do it. So if you're in the decimal, this is the thing that might be a little tricky. If you're in the decimal, you press tab. Tab gets you, fraction. Tab gets you out of the denominator. And now it's going to tell you, you might want a parentheses here. And we do want a parenthesis there. So type that parenthesis. Shift 6 is the caret. That caret moves you to the exponent. And then our exponent has multiple things in it. So this is where you're going to want to use another parenthesis. And type in 20 times 12. And what we've typed in should look very similar to what we've written on our paper. Should look very similar. The difference is that we do need parentheses up here. Otherwise, I'll show you what happens if we don't. Okay. If I write 20 times 12 and I don't use parentheses, notice that it doesn't think the 12 is in the exponent anymore. And the 12 really needs to be in the exponent. So that's why we write 20 times 12 with parentheses, so that it knows we're in the exponent. And then again, if we wanted to get out of the exponent, we would press tab again. And this gives us our answer. And we're talking about dollars. So we're going to round this to about $3,641.51. We're going to round it to the nearest cent. So there's a 9 after this, so 50 rounds to 51. And this is how much is in the account after 20 years. 20 years, really? Wow. Okay. Yes, 20 years. That's going to be our answer. The question in part B is how much interest will the nephew earn? Well, 3% interest compounded monthly for 20 years. Well, there's 2,000 of this was principal, right? This is the total amount. This is the principal plus the interest. I have to double check. I'm using the right principal, right? I am using the right principal. Okay. That's the principal plus the interest. Well, if we know the principal was 2,000, well, that means that 3641.51 is equal to the principal plus the interest. Well, to find out that interest, we just subtract over that 2,000, and we have our answer. The interest is whatever this difference is. So subtract 2,000, and you're going to get 1,641 and 51 cents. So a lot of interest in 20 years. Again, it's not really that much interest because of inflation, but we're not talking about inflation in this class. That's how you calculate interest. It's the total amount. The total amount is the principal plus the interest. So if you know the principal and you want the interest, just subtract it over. And that is compound interest. We have one more example with Professor Smart, and then we'll move on to an even messier formula for you. So example 7.5, we got Professor Smart. Professor wishes they were smart. Wants to save $20,000 for his newborn sons, named Child Genius. College education, these are interesting names. If the account earns 5% annual interest and he anticipates his son will attend college at age 16 years, how much should Professor Smart deposit today? So this one's a little different, right? This $2,000, this is not what he's depositing. We don't know how much he's depositing today anymore, but it's going to be the same formula. So let's write it down. E sub n equals P naught times 1 plus R over K to the NK. The difference now is that now we don't know this anymore. We don't know how much the principal is. We don't know what we're depositing. We know that we want $20,000 though. So we're going to still use the formula, but now this is the P that we know. Because we want $20,000 after 16 years. Newborn son now wants the money when the kid is 16. Wow, okay. It's early college, running start, I guess. So let's fill this in. What is our interest rate? 5%. So we're going to put 0.05. It's compounded annually. 5% annual interest. Compounded annually, that's once a year. So we're going to write a 1 times n is how many years? 16 years times k, which is still 1. So again, we're going to need a little algebra here. If we know what this number is, we can just divide this out to get the P naught by itself. You can use a calculator to figure out what is this number, because it is just a number. Or you can divide it out now. It's up to you. So if you divide it out now, it looks like this. Dividing by 1 doesn't change the number, so we can actually drop that 1. Similarly, multiplying by 1 doesn't change that number. We can drop that as well. It all depends on how you want to do it. 1 plus 0.05 to the 16 over here. Since we divided it out, they cancel. And we're just left with P naught equals all of this. 20,000 divided by 1 plus 0.05 to the 16. Type that into a calculator and you'll get that P naught. Well, let's type it in together. And we're going to get some more practice with Desmos. 20,000 / parentheses 1 plus 0.05 end parentheses caret, which is shift 6, caret, which is shift 6. There we go. 16. Now, before we write our answer down, let's double check. Does this look the same as what we wrote down on our paper? And yes, it does. So this is going to be our answer. And again, we're going to round to the nearest cent. We're going to say that's approximately, we need to deposit $9,162.23 into our kids' college account. So that in 16 years, we will have $20,000 for Child Genius's college education. All right, and that is compound interest. Have fun.